This is part 2 of module number 4, Linear Regression Modeling for STAT 560, Applied Business Research and Statistics. This is the result coming from the Excel application of regression for the example we discussed in part 1. You should have already seen the tutorial leading to this result. In this table we have 3 parts. One is the regression statistics above here, showing primarily the correlation element expressed as multiple R, only applicable when we have multiple regression analysis. The R square, which is the square of the coefficient of correlation. The adjusted R square, and we'll cover that later. The standard error associated with this regression, and the number of observations. The second part of this chart shows the ANOVA table. As discussed in Module 2, ANOVA is the analysis of variance test. And in this case is looking at the differences between residuals resulting from the regression analysis. The result of the ANOVA test is the calculation of what we know as significant F. The third part of the table is a test of the different parameters of the correlation, and in this case we have 2. One is the intercept, which is 75.28, and the other one is the coefficient that multiplies the independent variable, or minus 2.1785. Here we have some definitions on what multiple R square, adjusted R square, and standard error mean. So multiple R represents the strength of the linear relationship between the dependent variable and all independent variables considered. In the example above, we only had one independent variable. The R square is defined as the coefficient of determination. It is the most common measure of the goodness of fit of the least square line and equates to the square of the correlation coefficient. The adjusted R square considers the number of independent variables, or also known as predictors, and is reduced according to the number of variables. So the more variables, the lower the adjusted R square is relative to the R square before the adjustment. The standard error measures the dispersion of the regression errors, or residuals. We covered the ANOVA test on module number 2. In this case, is used to validate the regression model. It compares the variability of the sample values and the corresponding residuals, also known as regression errors. Under the null hypothesis, the dependent variable is not correlated with the independent variable. The significant F value represents the probability of rejecting the null hypothesis when the hypothesis is true. To validate the regression equation coefficients, expressed as beta 0, beta 1, and beta k, we use the student's t-test. Under the null hypothesis, the values of the intercept as well as the coefficients that multiply an independent variable are equal to 0, as expressed here. The alternate hypothesis then is that beta 0, beta 1, all the way to beta k are different than 0. The p-values obtained through the analysis represent the probability of rejecting the corresponding null hypothesis when that hypothesis in reality is true.